Okay, class, the things you should have out on your desk at this time are your two assignments from block day, the 6-4 and the 6 being the worksheet and 6-5 being the book page 390. Those two things should be on your desk, as well as your pencil and notebooks, because we're going to take notes as well. Okay, so let's get started with that. We are going to go over homework first. And I will start with worksheet 6-4, and there's a few of them that I'm going to go over. So everybody has this out. The ones I'm going to do, I will do 3, 8, 10, 11, 12, 14, 15, 20, and 22. Okay. You will need to remember how to use your double angles as well as your Pythagorean identities for these. So make sure you have your notes out from block day. Okay, so let's see if we can get this worked out. Okay, so I have 1 minus 2 sine squared, and the way I work that out is, first off, I see that there's a minus, and I see that there's a 2, so I recognize it to be one of my double angle identities, and it's right here. 1 minus 2 sine squared theta is cosine double the angle. So we do cosine double the angle. Cosine double the angle. So you end up with cosine of 36 degrees. It's not a special angle, so that is as far as you can go. Okay, number 11, 1 minus 2 cosine squared. Oh, I'm sorry, 8 first. 8. Okay, number 8 looks a lot like this one here. 2 sine theta, cosine theta. But it's flipped around. It's 2 cosine sine. But remember that multiplication is commutative. So since it's multiplication, it doesn't matter if you put cosine before the sine or sine before the cosine. It ends up all being the same. So this is this is sine of 2 theta. Sine of double your angle. Sine of 2 times 59. Again, there is no opposites because when you flip this one around, it's a multiplication, and multiplication is commutative. Okay, so sine of 118 degrees. And 118 is not a special angle, so that is it. Okay, this one always stumps people. Cosine squared 51 plus sine squared 51. It looks a lot like this. The cosine squared is first, the sine squared is second, but notice there is a minus sign. The double angle is a minus sign, and this is a plus sign. This is the Pythagorean identity. It is just 1. Now kids will often say, oh, but it's flipped around and the cosine squared is first. Does it matter when it's a plus sign? Correct, it does not. Addition is commutative. The order in which you write these with addition does not matter. So it's just 1. Okay, the reason I want to go over number 11 is I want you to recognize 1 minus 2 cosine squared is right here, but it's flipped around. Now this one's flipped around on a negative. If it's flipped around on a negative, does that matter? Yes, it does. That is the opposite. So this is the opposite of cosine of double the angle. Opposite, because it's flipped on the negative, double the angle. So negative cosine of 16 degrees, and that's as far as you can go. All right. Now this one has the minus like it should, but again, it's flipped around. It's supposed to be cosine squared minus the sine squared. And if it's flipped on the negative, that does make a difference. That means it's the opposite. So it's still cosine double the angle, but now it's negative cosine double the angle. Negative cosine double the angle. So negative cosine of 26 degrees. Now I did talk about this on block day, but I still have kids messing up and asking, should the cosine absorb the negative? If the negative was on the 26, yes, it would absorb, but since it's out in the front, it does not absorb. It stays there. It does not disappear. Okay, 14. Recognize that this is your tangent, 2 tangent, and then 1 minus tangent squared in the denominator. It is the same thing, only there's a negative there. Because it's just one term at the top with that negative, you could write it like this. That is the same thing. 2 times tan of 81 over 1 minus tangent squared of 81, and I just popped the negative out to the front of the fraction. This is the double the angle for tangent, so tangent double the 81, and then that negative sign, it's just the opposite out front. So negative tangent of 162 degrees. Kids often struggle with this one. They mistake this for the double angle. It looks very, very close, but if you notice, the double angle has 1 minus 2 sine squared, not 1 minus sine squared. And so kids freak out and, oh, there's a typo, Mrs. Torres messed it up, or I don't know what to do, I've never seen this before. It is not a typo. Think of your Pythagorean identity, which states that sine squared x plus cosine squared x equals 1. That's from last unit. Now, if this is the case, and I got 1, and I subtracted the sine squared to the other side, what would I be left with? Cosine squared x. In this case, x is 24, so cosine squared 24. There is no doubling the angle in this problem. Why? Because the Pythagorean identities did not double the angles. Cosine squared equals 1 minus sine squared of x. No double angle. That's where kids often mess up on the test. Okay, this one, I see some 2's there, so is it double angle? The closest it looks to is this. A few things wrong. There's no 2's on this one, and it's minus, not a plus. Plus is Pythagorean identities, but same thing, it does not have a 2 on Pythagorean's identities, so GCF it. Sine squared 15 plus cosine squared 15. So this is 2 times sine squared plus cosine squared is 1, so it is 2. All right, number 22, 2 cosine squared pi over 8 minus 1. Looks just like this right here. 2 cosine squared theta minus 1, exactly as is. It's not the opposite. So this is cosine of double the angle. Cosine of 2 times pi over 8. 2 pi over 8 reduces to cosine of pi over 4, or you can cross reduce from the get-go. 2 goes into itself once, 2 goes into 8 4 times. So cosine of pi over 4. And since pi over 4 is a special angle, you would get it wrong if you marked this. Pi over 4 is 45. Quadrant 1, it's going to be positive. 1 over root 2, or root 2 over 2 if that's the way you write it. All right. Got it? I hope you can take. I did a lot of them with you, so fix anything else that you may have messed up on or you were not clear about, and I will go over any other questions on Monday. Okay, if you would quickly take out the book page, 6-5, and I'm going to go over some 6-5 questions quickly. 6-5, page 39. No, page 390, sorry. Numbers 9, 21 through 30. Okay, first one I'm going to do is number 9, and I'm only going to do a piece of it. I'm not going to do all of it. This is what was given. This is theta, this is 4, this is 3, and that was all that was given. And I'm hoping everybody knows a squared plus b squared equals c squared, that this would be 5. I'm going to do A. A in the book is asking us to find sine of theta. That is review from Math 2. We actually did that lesson in Math 2 just this week. Sine of theta, sine is opposite over hypotenuse, opposite over hypotenuse, 3/5. That's it, you're done. That's what part A is. Okay, I'm going to jump to part F. F is asking us to find secant of 2 theta. Now, we do not have a secant of 2 theta formula, but we know that secant is equivalent to 1 over cosine, so I can write this as 1 over cosine of 2 theta. Now, what I'm going to do is focus here. I'm going to focus on this piece and then worry about the 1 over later. So I'm going to write it 1 over, going to expand it. You have choices. You have 3 choices. You make your choice, 1, 2, or 3. I'm going to choose the first one. You're more than welcome to try one of these 2 and see if we end up with the same answer. So 1 over cosine squared theta minus sine squared theta equals 1 over cosine is 4/5. Theta is gone, squared, take away sine of theta, opposite over hypotenuse, is 3/5. Again, the theta is gone, squared, 1 over 4/5 squared is 16 over 25. Take away 3/5 squared is 9 over 25. 1 over this fraction here, when you subtract 16, take away 9 is 7 over 25. And we've done with these enough times to know when you're dividing fractions, you multiply by the the reciprocal. 25 over 7 times 1 is 25 over 7. All right, 28, 4 sine x cosine x plus 1. And on this particular piece, it asked you to let's see, let me read the book. It's asking us to use the double angle formulas to rewrite the expression, use graphing, blah, blah, blah. We don't do that. Rewrite using your double angles. We don't have a double angle that looks like this at all. I'm going to cover this guy, the 1. And looking here, we have a double angle that looks somewhat close to this. It is sine of 2 theta equals 2 sine theta cosine theta. It's right here from yesterday's or block day's notes. 2 sine theta cosine theta. Okay, that looks closest to, and we did one kind of like this in notes. Again, I'm ignoring the 1. Don't think of it as a GCF, just think of rewriting. 4 is equivalent to 2 times 2. 4 is equivalent to 2 times 2. Sine x cosine x, and that plus 1 is still there. Okay, so this becomes this because 2 times 2 is 4 times sine x cosine x. And this is our double angle right here. So that becomes sine of 2x instead of theta. The coefficient is 2 and the plus 1 is still at the end. All right, 2 times 2 sine x cosine x is 2 times sine 2x plus 1. All right, 30. I'm just going to quickly talk about and let you finish. I will give you the one hint if you got stuck here to FOIL. FOIL, clean up, and then you will see it does turn out to be one of your double angle identities. Now, just a really quick suggestion, when I would FOIL this out, I wouldn't do all of these arrows, I would just do first and last. Because it is a conjugate type problem, what's going to happen, sorry about that bell, that was not the bell to let you go. What's going to happen here with the inside and the outside terms, they're going to cancel out. They're going to undo with each other. So I would just do cosine squared minus sine squared and go from there. You can do that later. All right, put all this stuff aside, take out your notebooks, and let's get ready for today's lesson. All right, this is 6-6, solve equations, and today's date is the 1st. Solve for x. 0 degrees is less than or equal to x, which is less than 360. We've done this before. This is just one time around your unit circle or one period. We're not going multiple times. All right, here we go. Number 1, sine of 2x plus cosine of x equals 0. All right, before we get to our tricks to try that we did last unit, there are some things I can do here. First off, even if this was a sine x, I'm just going to quickly cross it out. Don't do it on your paper. If this was a sine 2x plus sine x, those are not like terms. I'm hoping you guys recognize that. Those are not like terms. So I can't, even if it was a sine x, I could not combine them. But I'm hoping that this is screaming out at you, change me, look at me. I've dealt with this before. Double angles, we just did this on block day. What does that piece change to? To sine x cosine x plus cosine x equals 0. Again, that is coming from right here. Sine of 2 theta is 2 sine theta cosine theta. Sine 2x is 2 sine x cosine x. Now let's look at the big picture. And since it equals 0, I could use zero product property if I can factor, and I'm hoping you can see the GCF is cosine x. That gives me 2 sine x plus, don't forget what's left here, a 1. And then you can use your zero product property. Cosine x equals 0. 2 sine x plus 1 equals 0. Cosine x equals 0 happens in 2 places, 90 and 270. this becomes sine of x equals minus the 1 divide the 2. I'm hoping you guys can do that. If you can't do it all in one step, then take your time. Subtract the 1 and then divide the 2. Sine of x equals negative 1/2. Sine is negative. At what angle? What is your reference angle? 30 degrees. When your 30 is down, your sine is 1/2. But it's, let me write that down, 30 degrees. But it is negative, so which two quadrants is sine negative? All students take calculus. Sine is negative in quadrant 3 and quadrant, 3 and 4. So what is 30 degrees in quadrant 3? And what is 30 degrees in quadrant 4? Give you guys a few seconds to figure that out and write it down. $210 and $330. Number 2, 1 minus 3 cosine x minus cosine 2x equals 0. Again, I'm hoping that part is screaming out at you, change me, pick me. 1 minus 3 cosine x minus parentheses equals 0. Now we're faced with a dilemma. We have choices, opportunities, choices for cosine 2x. Cosine 2x, according to the formulas that we have here, we have 3 choices. I'm going to write them down quickly. Cosine squared x minus sine squared x. Change that to a 1, then it's minus double the sine squared x. Change that one to a 1, and then the cosine squared becomes double. Okay, so those are our 3 choices. Now, I promise you this, it does not matter which one you pick. Pick one and go, you'll end up in the same place at the end. But there will always be one that is a little easier to work with and less work in the long run. And that's the one you want to pick because you don't want to be working on a problem really long, especially on test day. Okay, so think about it. There's a cosine x here, a 1 here, and I'm going to change this. Would it make sense to use the first one that has cosine and sine, the second one that has the sine only, or the last one that has the cosine only? I'm hoping you said the last one, because why would I want to throw a sine in there or a sine squared if there is no sine in the problem? Do you see that? Again, since it doesn't matter which one I pick, I'm going to pick the easier one, and this is the easiest one because then everything will be cosine. And I can factor or combine like terms. Now, if you use one of these first two, it'll work. You'll just have more work and more steps in the problem. Okay, 1 minus 3 cosine x minus 2 cosine squared x plus 1, because I distribute that negative, equals 0. Regroup it. Oh, are these like terms? These are not like terms because that one's squared, so that one's not, but these are, and I'll combine those at the end. Okay, in the right order, negative 2 cosine squared x minus 3 cosine x, and then plus 2 equals 0. I do not want that negative coefficient here. Different ways of thinking of it. I'm just going to divide both sides by negative 1. And when I divide by negative 1, it changes all of my signs, not just the leading one. So positive 2 cosine squared x plus 3 cosine x minus 2 equals 0. Your choice, factor as is or use u substitution. I am going to use u substitution. Let u equal cosine x, but again, if you can do without, go for it. This is 2u squared plus 3u minus 2 equals 0. 2u squared plus 3u minus 2 equals 0. Double bubble. I know the only way to get 2u squared is 2u and u. I know the only way to get this 2 is 2 and 1. And we talked before about why that's a bad guess. Yes, 2 times 1 is 2, but this gives you a GCF right here. So that's not a guess you should waste your time with. So 1 and 2. There's not really a whole lot of guessing. I want it to be positive, so figure out what your signs would be. Minus plus. This is negative 1u. This is positive 4u, which gives me the positive 3u in the beginning, or in the middle. When I set these equal to 0, you can plug in the u back in and then solve, or solve and then plug in. I'm just going to solve. U equals 1/2, u equals negative 2, which means cosine x equals 1/2, and cosine x equals negative 2. Cosine is positive in 2 quadrants, 1 and 4. What's your reference angle? When is cosine 1/2? 60 degrees. Cosine is 1/2. So what is 60 degrees in quadrant 1? Obviously 60. And 60 degrees in quadrant 4 all the way around is 300. And cosine of 2x is negative 2. Negative 2 over 1. Does it make sense to have your hypotenuse bigger than your adjacent? It does not. Or think of it as a graph. Cosine oscillates between 1 and negative 1. Will it ever reach negative 2? It will not. So this piece is no solution. This is all you write for your answer. On the test, you do not need to give me no solution. If you just give me this, I will know that you understood that this part was no solution, and I would see it in your workspace as well. So 60 and 300 are the only answers. And I'm going to move on to number 3. Number 3, sine squared x minus cosine 2x equals 5/4. Okay, it does not equal 0, but I'll deal with that later and see what can be done, if anything needs to be done. Now, I have choices. Sine squared is a Pythagorean identity, but cosine 2x is a double angle, and that's going to be the one I change. Why? Because we have choices for cosine 2x, and when I'm solving, I don't want that 2 in there either. And when I change it, when I change the cosine 2x, there are no 2's in there. Do you see that? Okay, so like before, we have 3 choices. So which one do we want to use? Let's look at the big picture. I have a sine squared in there, so let me write this out. I have sine squared x minus parentheses equals 5/4. Now, what am I going to plug in here since I have choices? Now, there's a sine squared already and nothing else. There's no cosine squared, just a sine squared. So, would it make sense to use the first that has both, the second that has just sine squared, or the third that has just cosine squared? I'm hoping you're saying, oh, the second because that's the one that has just sine squared. Why would I throw a cosine squared in there if there's no cosine squared in the problem? So making the wiser choice. The other ones would work, but you're going to end up with more steps. 1 minus 2 sine squared x. So distribute your negative. Sine squared x minus 1 plus 2 sine squared x. Put it in the right order, or first let's look for like terms. And if you look, oh, lo and behold, these are like terms. 1 sine squared x plus 2 sine squared x is 3 sine squared x. Take away 1 equals 5/4. Now I'm not going to use the zero product property here because I'm not factoring. I'm going to get sine squared x by itself by adding 1, which is the same as adding 4/4. Do you guys see what I did there? I added 1 to cross this out, and 4/4 is equivalent to 1. 3 sine squared x equals, what is that? 5 plus 4 is 9/4. Now I still need to isolate the sine squared x, so I divide by 3, but I don't like to divide when I already have a fraction, so I'm going to multiply by the reciprocal. Again, I can divide by 3, but I don't like to divide by 3 when I have a fraction on either side, so I multiply by the reciprocal. Sine squared x equals, cross reduce here, 3 becomes 1 and 9 becomes 3. Do you guys see what I did? I cross reduced 3 and the 9, 3 goes into itself once, 3 goes into 9 3 times, and now we're ready to square root both sides. Boom, boom. Sine of x equals, do not forget your plus or minus. Some kids did forget that on the test, the last unit. So root 3 is root 3 and root 4 is 2. Sine of x equals root 3 over 2. What's your reference angle? 60 degrees. And is 60 degrees one of your answers? Yes, it is, because you're in all 4 quadrants. If sine is plus or minus, it's positive in the top 2, negative in the bottom 2. You're in all 4 quadrants. So what is 60 degrees in all 4 quadrants? I'll give you just a few seconds to list them all out. $60, $120, $240, $300. And these are all definite test questions. Number 4, 2 sine 2x cosine x plus sine 2x equals 0. Okay, so you're looking at what you can change. Again, paying attention to, actually, before we look at what we can change, we will be changing stuff. We will. And I'm hoping you recognize that it's a sine 2x that we're going to want to change. Actually, we may not change. Let's just look at the big problem. Sine 2x plus sine. Can you see that there is a GCF? Do you guys see that? GCF? Yes. Okay, so take it out. And that gives you sine 2x parentheses 2 cosine x plus 1 equals 0. That's a 2x, not a squared. I know it looks a little high, but that is a 2x, not a sine squared x. All right. Zero product property. Sine of 2x equals 0. And this is 2 cosine x plus 1 equals 0. Now this I know I said I'm going to change, but I'm not going to, you could use your 2 sine theta cosine theta, but I'm just going to use the fact that 2x means you're going twice around. Once, twice. So when is, you can substitute sine of theta equals 0. Theta equals 2x. And when is sine of what angle is 0? 0 and 180. That's your first set. And what do you do to get your second set? Add 360 to each one. Do that now. $360 and $540. And then because it was 2x, you go through and divide everything by 2, including the small angles in the beginning, not just the ones that are bigger than 360, the smaller, all of them, from the beginning to the end. So that gives you what? 0, 90, 180, and 270. I'm going to clean that up a little bit. 0, 90, 180, and 270. All right, now we need this one still. Subtract your 1, divide by 2. Cosine x equals -1/2. What's your reference angle? Cosine of what angle is 1/2? 60 degrees. When is cosine negative? Quadrants 2 and 3. So quickly find your 60 degrees in those two quadrants. $120, $240. Okay, that's it for the lesson. Today's assignment is a worksheet 6. The sub will be handing that out to you. Keep in mind there's 2 sides to that worksheet. One side is worksheet 6. The other side is worksheet 7. Worksheet 7 we will not be doing until Monday. So you're only doing one side of the half worksheet. So you will get a half worksheet that looks like this. This is worksheet 6. You'll do it on a separate piece of paper. This is worksheet 7, also done on a separate piece of paper, but this will not be done until, we won't do this until Monday. So this is the only assignment you're doing tonight. Worksheet 6 on a separate piece of paper. And I will not see you until Monday, so enjoy your weekend, have fun, be safe, and make good choices.